Hello everyone. The present video explains the chapter solutions for the class 12 students part 1, and in this video I am going to explain the definition of solution and different methods of concentrations. Please subscribe to my channel GVS Chem at 4093. Please like and share my videos. Solutions chapter. What is a solution? A solution is a homogeneous mixture of two or more different substances. Solution is a homogeneous mixture of two or more substances. So, in most of the cases, we come across solutions of two types of different substances. So, the two components of solution are solute and solvent. Solute means the substance which can dissolve in other substances. Dissolves in other substances. Solvent means which can dissolve other substances in it. Can dissolve other substances in it. In general, solute is in less quantity, solvent is in more quantity. So let us see an example. Solution of salt. So here in this example, salt is a solute, water is a solvent. In the same manner, sugar solution. So in sugar solution, sugar is a solute and water is a solvent. Now let us see the binary solutions. Binary solutions are those having only two components. That is solute and solvent. For example, salt plus water, sugar plus water. Ternary solutions means solutions having three components, that is three components in which one component is a solvent, that is water plus sodium chloride plus potassium chloride. This we can take it as an example of ternary solutions. Right. Now, aqueous solutions. Aqueous solutions means those solutions having water as solvent. So aqueous solutions have water as solvent. Those solutions having water as solvent are called aqueous solutions. There are certain solutions in which water is not present as solvent. That means apart from water, other liquid may be present as a solvent. That is sulfur dissolves in carbon disulfide. So this is referred as non-aqueous solution. Similarly, camphor dissolves in benzene C6H6. So this is also non-aqueous solution. In these two examples, water is not present as solvent. Other solvents are present apart from water. The solvents present are carbon disulfide, benzene, etc. So these solutions are referred as non-aqueous solutions. Now let us discuss the types of solutions. Types of solutions can be classified based on the physical state of the solvent and solute. So gaseous solutions. Gaseous solutions are those in which the gas is present as solvent. So solvent, physical state, solute, and examples. So solvent here is gas, solute is solid, sublimation of solid in gas. So solid sublimes into the gas. For example, camphor sublimes in nitrogen gas. So this is an example for solid solvent, gaseous solvent and solid solute. Similarly, gaseous solvent and liquid solute, water vapors in air. So gaseous solvent and gas solute, mixture of gases. So mixture of gases is an example of gas solvent. Next, liquid solutions. In liquid solutions, liquid is taken as a solvent and remaining three states of the substances are present as solute. So solute, solvent and examples. Liquid as a solvent and a solid is a solute, salt in water. So this is the very common example in day-to-day life. Similarly, sugar in water. So here, water is solvent and salt and sugar are solutes. So liquid solvent and liquid solute, alcohol present in water. Not only alcohol present in water, any two miscible liquids we can take. So N-heptane and N-octane, carbon tetrachloride and methylene chloride. So there are so many examples. So liquid solvent and gas solute, carbon dioxide in water. In water, many substances, many gaseous substances are dissolved. For example, the dissolved oxygen gas is meant for sustaining the life of aquatic animals. Solid solutions. Here, in this type of solution, solid is a solvent and different physical states of the substances are taken as solute. So, solvent, solute and examples. Solid solvent and solid solute. Here, examples are alloys. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. So, brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Steel is an alloy of iron and carbon. There are many types of steels are there. Similarly, solid solvent and liquid solute. So amalgam. Amalgam is the mixture of mercury and any metal. So mercury is the liquid solute and solid is metal. So zinc amalgam is an example of solid solution in which zinc is a solvent and mercury is the solute. And solid gas. Example for this is adsorption of gases. So gases are adsorbed on metal surfaces. For example, hydrogen gas is adsorbed on nickel in the process of hydrogenation of unsaturated hydrocarbons into saturated. Concentration of a solution. Concentration means concentration refers to the amount of solute present in the solution. So concentration refers to the amount of solute present in solution. Amount of solute present in solution is referred as concentration. So concentration can be expressed in different methods. So concentration methods. Concentration methods are: number one, mass percentage, W by W percent. Next one is volume percentage, V by V percent. Then molarity. Next one is molality. Normality. Next one is normality. Sixth one is mole fraction. And seventh, parts per million. Parts per million. So these are the different methods of concentration of solution. Now let us discuss about each and everything method of concentration. Now mass percentage. Mass percentage W by W percent means it is the amount of solute present in 100 grams of solution. So amount of solute present in 100 gram of solution. 100 gram of solution. Amount of solute present in 100 gram of solution is referred as a mass percentage. So mass percentage can be written as mass percentage equal to mass of the solute by mass of solution. Mass of solution into 100. Mass of solute by mass of solution into 100. Now let us take an example. 10% salt solution. 10% salt solution means 10 grams of salt is in 100 grams of solution. Is in 100 gram of solution. That means 10 grams of salt is dissolved in 90 grams of water. So this is a total mass of solution. In the total mass of solution, 10 grams of salt is there. Remaining is a solvent, that is water. So 10 gram of salt is in 90 gram of water. So this is a mass percentage. Now let us see volume percentage. Volume percentage. Volume percentage V by V percentage. So what is this? Just like mass percentage, in the mass percentage we took the mass of solute and solvent in grams. Now here we take volume of the solute and solvent in milliliters. So volume of solute present in 100 ml of solution. 100 ml of solution. Volume of solute present in 100 ml of solution is called volume percentage. Volume percentage. So if 10 milliliters of alcohol, 10 milliliters of alcohol is dissolved in 90 ml of water, 90 ml of water, then it is referred to as 10% alcoholic solution. 10% alcoholic solution. So volume of the solute is, that is alcohol is 10 ml, volume of the water, that is solvent, is 90 ml. So total put together 10 plus 90 is 100. Therefore in 100 ml of solution, 10 milliliters, 100 ml of solution, 10 milliliters of alcohol is present. Therefore it is referred as a volume percentage. So volume percentage is written as volume of solute by volume of solution. Volume of solution into 100. Volume of solute by volume of solution into 100. So this is volume percentage. Next one is molarity. Molarity. Molarity is denoted by capital M. Molarity. Molarity is the number of moles present in 1 liter of solution. Number of moles of solute present in 1 liter of solution. Number of moles of solute present in 1 liter of solution. So here, therefore, molarity equal to number of moles of solute by volume of solution in liters. Volume of solution in liters. So molarity equal to number of moles of solute by volume of solution in liters. Now let us move it to further extent. Now how do we find the number of moles? Number of moles can be found by given mass by molar mass. So molarity equal to given mass by molar mass divided by volume of solution. Volume of solution, in most of the cases it is given in milliliters. So we know that 1000 ml, 1 liter equal to 1000 ml. So the volume given in milliliters can be converted into liters by dividing with 1000. Therefore, volume, let us say VML by 1000. This is nothing but given mass can be represented by W, molar mass can be represented by M, W by M, then it is reversed 1000 by VML. So molarity equal to 1000 by VML. Molarity equal to 1000 by VML. Put this in box. So an important formula. In the same manner, now let us find the next method, molality. Molality, M-O-L-A-L-I-T-Y, molality. It is the number of moles of solute. Number of moles of solute present in 1 kilogram of solvent. Here we take solvent, whereas in molarity we took solution. So it is the number of molarity is the number of moles of solute present in 1 kilogram of solvent. So molality is denoted by small m. Molality equal to number of moles of solute by number of moles of solute by mass of solvent in kilograms. Mass of solvent in kilograms. So number of moles, how do we find? Given mass by molar mass divided by mass of solute in kilograms. Always mass may not be given in kilograms, therefore it may be given in grams. So let us say it is G grams of solvent by grams can be converted into kilograms by dividing with 1000. Therefore it is 1000. Therefore this is nothing but W by M into 1000 by G grams of solvent. This is molarity. So molality equal to molarity M equal to, this is the formula. So put this in box. It is another important formula. Now for discussing the normality, we must know about the equivalent weight. First of all, equivalent weight or equivalent mass. Equivalent weight of an element is the ratio of its molar mass to the valency, to its valency. So equivalent weight of element is molar mass molar mass by valency. Now equivalent weight of sodium. What is the molar mass of sodium? 23. Its valence is 1. So 23 by 1 is 23. In the same manner, equivalent weight of magnesium equal to molar mass of magnesium is 24 by its valency 2. Therefore it is 12. In the same way, equivalent mass of aluminum, it is 27 by 3 equal to 9. So that is equivalent mass of elements. Now let us see the equivalent mass of acids. Acids is the ratio of its molar mass to its basicity. Equivalent mass of acid is the ratio of its molar mass to its basicity. So what is the basicity? Basicity means, basicity is the number of replaceable H plus ions per molecule of an acid. Basicity of an acid is the number of replaceable H plus ions per molecule present in that acid. Therefore, thus HCl, HNO3, hydrochloric acid, nitric acid, nitrous acid, all these they have only one replaceable H plus ion. Therefore, they are referred as monobasic acids. Similarly, equivalent mass of bases. So just now we discussed the basicity of acid. So HCl, HNO3, HNO2, HCN, all these are monobasic acids. So what is the equivalent mass of acid equal to molar mass by basicity. So molar mass of HCl how much? Equivalent mass of HCl equal to molar mass 36.5 by 1. Basicity is only 1. Therefore it is 36.5. Similarly, nitric acid 63 by 1 equal to 63. So these are monobasic acids. Dibasic acids are H2SO4, H2SO3, carbonic acid H2CO3, sulfuric acid, sulfurous acid, carbonic acid, etc. So equivalent mass of H2SO4 equal to of sulfuric acid is 98 by its basicity 2 equal to 49. So like that, by taking the ratio of equivalent mass to its basicity, we can find the equivalent mass of acid. In the same manner, acidity of base. Let us discuss acidity of base. Acidity of base is the number of replaceable OH minus ions. Number of replaceable OH minus ions in base is referred as acidity of base. NaOH, KOH, NH4OH, all these are referred as monoacidic bases. Monoacidic bases. In the same manner, CaOH twice, magnesium hydroxide MgOH twice, barium hydroxide BaOH twice, all these are diacidic bases. Diacidic bases. Similarly, triacidic base is, what is triacidic base? Triacidic base is aluminum hydroxide. Triacidic base, it has 3 replaceable H plus ions. Equivalent mass of base equal to molar mass by acidity. So equivalent mass of any base is found as molar mass to its acidity. So equivalent mass of sodium hydroxide equal to sodium hydroxide molar mass is 40 and its acidity is 1. It has a 1 replaceable OH minus ion, therefore 40. Similarly, CaOH twice calcium hydroxide 74 equivalent mass of calcium hydroxide is ratio of molar mass to its acidity. Molar mass is 70 and it has 2 OH minus ions, so its acidity is 2, therefore it is 37. Similarly, equivalent mass of aluminium hydroxide, aluminium 27 and hydroxide 17, 51, 8, 78. So this is 78 by 3. This is 2, 26.6 is taken as 27. So equivalent mass of aluminum hydroxide is 27. Now let us see normality. Normality N is defined as the number of gram equivalent weights present in 1 liter of solution. Present in 1 liter of solution. So if equivalent mass is expressed in terms of grams, it is nothing but gram equivalent weight or gram equivalent mass. So therefore, normality equal to number of gram equivalent weights, by volume of solution in liters. Volume of solution in liters. Normality equal to number of gram equivalent weights by volume of solution in liters. So how do we get the number of gram equivalent weights? This is given mass by equivalent mass divided by volume of solution. Volume of solution may be given in milliliters, therefore it may be VmL by 1000. This is nothing but given mass by equivalent mass into 1000 by VmL. So this is W by EQ into 1000 by VmL. So this is the formula for normality. Normality N. So keep this in box. Now let us discuss mole fraction of solute or any component in the given mixture. So mole fraction. Mole fraction means it is a ratio of number of moles of any one of the components to the total number of all the components. So mole fraction. So mole fraction is the ratio of number of moles of any one of the components to the total number of moles of all the components. Suppose if there are two components, if A and B are two components in the mixture, XA and XB are mole fractions. XA and XB are mole fractions of both the components, then and NA and NB are the number of moles of both the components. If A and B are two components in the mixture, then XA and XB are mole fractions of those two components and NA and NB are number of moles of those two components. Then mole fraction we have, then mole fraction of A is A, XA equal to NA, that is number of moles of component A by number of moles of component A plus number of moles of component B. So this is the mole fraction of A component. In the same manner, mole fraction of B component, XB equal to NB by NA plus NB. So if we add these two, we get 1. That is, number of moles of sum of the mole fractions of all the components in a mixture is 1. Now let us discuss another method of expressing the concentration of the solution is parts per million, ppm. Generally, this parts per million method is used in the case where the amount of solute is very, very small, minute. For example, the air pollution is measured in terms of ppm. Similarly, this method is widely used in pharmaceutical industries. Now let us see what is the parts per million. Parts per million, the number of moles, number of parts of solute, number of parts of solute present in 1 million parts of mixture. 1 million parts of mixture. Parts per million is expressed as number of parts of solute present in 1 million parts of mixture. Mixture means it is solute and solvent. So ppm equal to parts means number of parts. So this is number of parts of solute. Solute means in case of air pollution, the contaminating molecules like nitrogen dioxide, sulfur dioxide, etc. So number of parts of solute by total number of parts of solution into 10 to the power 6. 10 to the power 6 means 1 million, that is 10 lakhs. So these are the concentration methods. In the next video, let us discuss some numericals based on all these methods of concentrations of solution. Thank you. Students are advised to revise this lesson and prepare well for examination.